Now we'll discuss about wedge-shaped film. See, this is a wedge-shaped film. This is maybe a soap solution of refractive index mu. This is air. So this is a wedge-shaped film. You can see the thickness is increasing. The thickness goes on increasing as you move in this direction. Thickness goes on increasing. Now you have a beam of light incident on the wedge-shaped film. So this is wedge-shaped film. Beam of light incident. It is almost normally incident on the film. This is the light which is reflected from the upper surface of the film, and this is light which is reflected from the lower surface of the film. So we will consider the interference between 1 and 2. 1 is getting reflected from the upper surface of the film, and second beam is reflected from the lower surface of the film. So if suppose T is the thickness, the path difference, see we are considering interference between 1 and 2, the path difference is going to be 2 mu T. This is going to be the path difference. We are considering normal incidence. And since 1 is getting reflected from rarer to denser interface, so 1 will suffer a phase change of pi. 2 is getting reflected from denser to rarer interface, so 2 won't suffer a phase change of pi. And since 1 will be suffering a phase change of pi, suffering a phase change of pi is equivalent to traveling a distance of lambda by 2. So this is the path difference. For maxima, this path difference should be equal to n lambda, or 2 mu T will be n plus half lambda. For minima, this can be written as, for minima, the condition is delta x equals to n minus half lambda, and this becomes 2 mu T n minus half lambda, or the condition will be 2 mu T equals to n lambda. This is for minima. The thickness T should be such that 2 mu T equal to n lambda. That will give you the minima. The thickness for which 2 mu T is n plus half lambda will give you the maximum. Now if I ask you what is the locus of point on the film, so that below which the thickness of the film is T, what is the locus of this point P? Suppose this is point P. Locus of point P such that the thickness of the film below that point is T. That will be obviously a line. That will be a straight line. So the film, this will be locus of point P such that the thickness of film is T is given by straight line. Below all these points, your thickness of the film will be T only. So the fringes will be in the form of straight lines. Fringes are of the form straight line. They will be in the form of straight line. Now if you are interested in getting the position on the film, then I can write T as, this T can be written as xn sine theta, or this will be xn theta. So the condition of maxima will become 2 mu T xn theta equals to n plus half lambda, or the position of maxima is theta, right? And the position of minima xn dash becomes n lambda upon 2 mu theta. So if you want the fringe width is going to be xn minus 1, that becomes equal to lambda upon 2 mu theta. That is lambda upon 2 mu theta. That is the fringe width. This is the fringe width. So this is how the fringe get formed on the wedge set film. The thickness go on increasing linearly over here. Now I'll move on to your Newton's ring, right? Now I'll discuss the Newton's ring, where the thickness of the film will be increasing, and an increase will be more than linear. It won't be just linear increase. The rate of increase will also increase. So let me draw the Newton's Newton's ring. Let me discuss Newton's ring. In case of Newton's ring, you have a plano-convex lens. We have a plano-convex lens placed on a glass plate. I'll draw this. This is plano-convex lens placed on a glass plate, right? This is a plano-convex lens placed on the glass plate. Light is incident almost normally on this plano-convex lens. It gets reflected from the surface, and a part of light will get refracted. It will be reflected from the lower surface, right? Lower surface. Here the film is, this is the film. This is a film. The thickness starts from 0 and increase rapid compared to the wedge set film. So the thickness is increasing. Thickness is increasing over here. Thickness go on increasing. We will be considering, say this is the film. This is the film. Say this is your film. I'll draw it yellow. This is your film. This is the film. Right. This is the film. It's 3-dimensional. On the paper it will look 2-dimensional. It's 3-dimensional. So this film, and we are considering the interference between the rays. This is the incident beam. We are considering the interference between the ray which is reflected from the upper surface of the film and between the ray which is reflected from the lower surface of the film. Suppose right now, let me consider this to be air. So this is air film, right? This is air film, and the point where it falls, we'll call this point P. Let's say the thickness of the film below point P is T. In that case, the part difference between 1 and 2, since we are considering the interference between the rays which are reflected from the upper surface of the film and lower surface of the film, so the part difference will be equal to 2t, and this 2t, this is the part difference. Let me write the part difference is delta x is 2t, right? And you will see over here, see this beam number 1 is getting reflected from denser to rarer interface, so it won't suffer a phase change of pi. This is glass, this is air, so this is denser, this is rarer. But ray number 2 is getting reflected from rarer to denser interface, so 2 will suffer a phase change of pi upon reflection. So apart from traveling a distance of 2t, in addition to this, it also suffers a phase change of pi, that is traveling or suffering a phase change of pi is equivalent to traveling a distance of lambda by 2. So 2t, it will travel a distance of 2t plus it suffers a phase change of pi, so that is equivalent to traveling a distance of lambda by 2. So part difference becomes 2t plus lambda by 2. Now for maxima, this delta x must be n lambda, or this will be 2t plus lambda by 2 equals to n lambda, or 2t n minus half lambda. For minima, this delta x should be equal to n plus half lambda and 2t plus lambda by 2 equals to n plus half lambda, that is 2t equals to n lambda. You might say, why you have not taken n minus half? You can take n minus half. If you take n minus half lambda, then it will be n minus 1 lambda, and in that case n will begin from here. N is beginning from 0, 1, 2, 3, 4 like this. If you take n minus half, here you will get n minus half lambda, and there n will begin from 1. So you can write it n lambda, or you can write it n minus 1 lambda. N minus 1 lambda, then the value from which n will begin will change. So or this can be n plus 1 lambda also, as you wish. If you write n plus 1 lambda, then n will begin from minus 1, right? Here n is beginning from 1, you can't have minus 1, sorry, it can't have 0, n will begin from 1. If you write n plus half, n will begin from 0. So you can write anything, but then depending on what you write, the initial value n will begin from the value that will depend on what you write over here. So this is 1, 2, 3, 4 like this. Now if I ask you a very simple question, what is the locus of point P below which you have a film of thickness T? What is the locus of point P below which you have the thickness T? Thickness of the film is T. You can very well answer this. This is a circle. These are the points below which you have the film thickness equal to T. So if you have a maxima at point P, the locus of all the maxima will form a circle. So naturally we are interested in what is the radius of this circular ring. It will form a kind of ring. The maxima will form. If you have maxima at point P, the locus of such point is a circle, right? So you have a maxima and minima in the form of ring. We call it bright ring, we call it dark ring. Bright ring and dark ring. So we are interested in finding out the radius of that bright ring that corresponds to nth maxima, radius of dark ring which corresponds to nth minima, right? So let's try to find out what is the radius of that ring. For that I have to draw this, I have to produce this curvature and make the whole sphere. And let me do it. Let me draw the figure again. Here I have produced this curvature, I made the whole sphere. This is the glass plate, and say this is point P. This is your point P. Now, so if this is point P, the radius is, this is going to be, rho is going to be the radius. Rho is going to be the radius of the ring, right? Let me call it O. This point is O, and this is say A, right? And I call it B. Now you want PB, right? Suppose the radius of curvature of the lens is R, so AO is going to be 2R. So you might have read in your 9th class or 10th class similar triangles, right? And in similar triangles you find a theorem called Pythagoras theorem, and before that theorem you might have read one theorem which leads to Pythagoras theorem. In fact, if you have a similar triangle like this, this is 90 degree, this is 90 degree, this is A, B, C and D. In that case AD square is BD into DC, right? See, if I apply the same thing over here, say this is 90 degree, this is also 90 degree, this is a semicircle, a triangle in a semicircle, so this is 90 degree. So in that case, if I apply this formula, this is PB square is AB into BO. You must remember this one. You have read it in your 9th class. So this is AB into BO, right? So PB square is rho square and AB is what? If suppose the thickness of the film over here is say T is the thickness, then AO is 2R, so AB will be 2R minus T, and this is T, so this is 2RT minus T square. And this is planar convex lens. T is a very high curvature, radius of curvature. T is very small compared to R, so I can say rho square is almost equal to 2RT. Now for the bright ring, you have the condition 2T equals to n plus half lambda. I hope you had this condition, right? So 2T will be written as rho n square corresponding to nth maxima, rho n square upon 2R, or radius of the bright ring corresponding to nth maxima is going to be, I can write this as, oh, this is rho n square by R, right? 2 won't be there. So rho n comes out to be n plus half lambda r under root. N equal to 0 will correspond to first bright ring, n equal to 1 will correspond to second bright ring, and so on. If you write here n minus half, then n equal to 1 will correspond to first bright ring. You can write minus half also. I don't remember what I wrote. I love this. So you can write n plus half, you can write n minus half. If n minus half, n will begin from 1. N equal to 1 will correspond to first bright ring. If it is n minus half, n plus half, n equal to 0 will correspond to first bright ring. I hope you understand. Don't confuse between n plus half and n minus half. In the exam, you can write n plus half, you can write n minus half. Even you can write n plus 3 by 2 also. In that case, n will begin from minus 1. N will begin from minus 1. You can begin from n minus 3 by 2 also. There n will begin from 2. But don't do it. Right? It's not wrong. But then why you should give pain to the examiner? Right? The examiner will get puzzled. N plus 3 by 2. You don't write n plus 3 by 2. But you can write, but you don't write it. That's my advice. So you can write n plus half, you can write n minus half. Right? So this is the radius of the bright ring, where n equal to 0 will correspond to first bright ring. If it is n minus half, n equal to 1 will correspond to first bright ring. Now let's consider dark ring. See, if I have written n minus half, you write n minus half only. Right? I don't remember what I wrote. 2t equals to n plus half, n minus half. I wrote this. So dark ring, in case of dark ring, you have 2t equals to n lambda. That is, rho n square is n lambda, or radius of the dark ring is n lambda r. N lambda r. Right? This is n lambda r, where n equal to 0 will give you dark spot. You have dark spot over here, and n equal to 1 will give you first dark ring, and so on. Right? N equal to half will give you the first dark ring. Remember this? Now suppose, so this is, remember this, right? But when you are given the question, you start from here, right? Start from here. Don't write the formula and calculate. Start from here, and then you solve the problem. Okay? If you just put the formula, then if it is subjective question, examiner will give you, it's better, right? You start from here. You start from the part difference, right? And then go on. Now suppose I'm giving you a very, very important case. Suppose earlier this was air. I derived this when it was air. Now suppose I fill this with a special material called sassafras oil. Sassafras oil. Don't laugh. It's sassafras oil. Suppose this is crown glass, and say flint glass. See, for crown glass, the refractive index is 1.5. For sassafras oil, 1.55, and for flint glass, it is 1.6. So in this case, since one is also getting reflected from the rarer to denser interface, beam 2 is also getting reflected from rarer to denser interface. This is 1.55, this is 1.5, this is 1.55. So beam number 1 is also getting reflected from rarer to denser interface. Similarly, beam number 2 is also getting reflected from rarer to denser interface. So both are suffering a phase change of pi. And since both are suffering a phase change of pi, their part difference will be just 2 mu t. Right? We have to multiply mu because now this is filled with sassafras oil, which has got a refractive index of 1.55. So for bright ring or for maxima, the condition will become 2 mu t should be equal to n lambda. and 2t is your 2t is rho n square by r, that is n lambda upon mu over here, right? N lambda upon mu. So radius of the bright ring will be n lambda r upon mu. N equal to 0 will give you the bright spot. See, earlier you had dark spot, now it is bright spot. Spot at the center will be bright spot, and n equal to 1 will give you first bright ring. N equal to 1 will give you first bright ring. In case of dark ring, this will be n minus half lambda, or 2t will be rho n square by r, that is radius of the dark ring is n minus half on mu, where n equal to 1 will give you first dark ring, n equal to 2 will give you the second dark ring, and so on. So the condition, the formula for bright ring and dark ring gets interchanged. It gets interchanged over here. So that's the difference. That's the difference when you fill it with a sassafras file. And this is very important case. Please keep in mind, very important.